In this question, we've been told that the discrete random variable x is modeled as being geometrically distributed with a parameter 0.2. The parameter for geometric distribution is p, the probability of success. We're first asked to state two conditions that must be satisfied by x so that the geometric model is valid. Okay, so geometric distribution. Just like many distributions, we are relying on the fact that the trials are independent. What happens in one trial does not impact or impede what happens in another trial. Secondly, the trials have a constant probability of success. That's how we know we can use 0.2 all the way through our working out. It's always 0.2 no matter what happens. In part B, we're asked to find the probability that x equals 3. Well, x is the number of attempts before we have our first success. So if it's 3 attempts before our first success, that means that the first 2 attempts were both failures. So we're going to find the probability of 2 failures followed by a success. 0.8 squared times 0.2, and that gets us 0.128. Part 2, the probability that x is greater than 8. The probability that we need more than 8 attempts before we have our first success. Firstly, we always rewrite this with an equals to. So the probability that x is greater than or equal to 9. If we needed 9 or more attempts to get our first success, that means we have definitely had 8 failures. So this is the probability of 8 failures, q to the power of 8. That's 0.8 to the power of 8, and that's 0.1678. And finally, the probability that is in between two values. So we have the 5 being equal to, but the 13 is not. So my very first step, before I think about anything else, is to rewrite with equals to's. So x is in between 5 and 12. We're including 5, we're including 12. Okay, well, we can find this splitting it into the probability x is less than or equal to 12, subtract the probability x is less than or equal to 4. Each of these we can find individually. If we saw our first success before or on our 12th attempt, we know we didn't have 12 failures. It was impossible to get to the point of 12 failures. So it's everything except for having 12 failures, which is 1 minus failure to the power of 12. Similar thinking for less than or equal to 4. We can do some nice rearranging here. The ones cancel out. Q to the power of 4 minus Q to the power of 12. Okay, substituting in 0.8 to the power of 4 minus 0.8 to the power of 12 leaves us with 0.3409.